Hey again, guys. So, I thought I was going to mention something that came up as a topic in my interview with Klarna, and it's something that hasn't been, it's not the first time I've had this discussion. The first time I was asked about it was actually by my colleague. So, to give you a bit of context, one of the things I'm a big advocate of using named functions in JavaScript more like for almost everything. Like the my rule of thumb is that if I see a function or a body with a condition or like anything that has logic inside of it, unless that logic is strictly doing like trying to do something that is, it doesn't really make any sense to make it into a function. Like if you're incrementing a number or like something really trivial, I don't think that there's much value in breaking that out if it's already inside of another function. So what I'm trying to say is that I want to have like Boolean expressions and any type of question or execution of code that provides what I call business logic to be in a named function. And some people, like in JavaScript, this isn't all that common. Like there's a more people than not are always putting everything in a lambda function. So you create some type of top level function that takes in a parameter, and then you do a lot of mutations and different computations. And for the most part, I see things like you'll create a for loop with an array above the for loop, and then you'll push a bunch of values into that array. And I keep asking people, why are you doing that? Just make it into a function that returns the array. Why put the for loop with everything else? Separation of concerns, right? And apart from that, you'll see people use map and filter and sorting and all that stuff, and I see it all the time. They make every like the input function to these methods a lambda function, and I don't like to do that. And the reason why I want to use named function is because I personally feel that it's more readable, and it also creates what I call a healthy abstraction layer on top of business logic. And that's where this discussion came in. Well, I had the scenario where I had an if condition where the function that was like for intents and purposes, the function was taking in two different objects, and the if condition would run the code based on whether or not two Boolean values were both true on the object that the function was provided with. So what I did was that I created another function that took in these two Boolean values, and I named it should run code, or should, it's not that exact name, but I said should run code. And then and that was the entire story. And my colleague came over to me and said, like, Frederick, why did you do this? And I said, well, because I didn't see a reason not to do it. I think it was more descriptive. And he said, well, he was got a little bit emotional about it. And he said, well, Frederick, I mean, if you were doing something, like, now you're fooling me into believing that computation was something big. Like, to answer that question, you made me feel that it needed a function because there was so much complexity that it had to be a function. But then I looked inside the function, and it was just an or, like an and, like a Boolean plus a Boolean and Boolean like computation. And that, I think that's less, like, it makes me a little bit, I don't like that. That's a code smell to me. That's what he said. And so I turned to him and I said, well, do you are you really thinking about that properly? Because, like, let's just imagine for a moment that I didn't put it in a function, and I just put the Boolean value as is, like that evaluation in the if condition. What would that solve for you? Like, that's basically imperative programming. And I mean, this is not a big deal, but why would it make a difference to you if it's two Boolean values? Would you still feel that I should keep it inside of that if condition as is if there was 3 or 4 or 5 or 20? Where do you draw the limit for when it's time to, like, because in my opinion, like, the decision to abstract logic into a function with a descriptive good name
should not be made based on how much logic there is. It should be based around, does this provide like readability and value? And I argue that this does provide both, or at the very least, it doesn't make things less readable. In fact, even if it made it like if it's exactly as readable, this is at the very least testable. Let's say that, for the sake of argument, that this condition that we're checking now changed over time, and maybe the complexity just grew. Then at the very least we could because we are supposed to test this. So if we now test this condition, this function that I made, and the specification of what's going to be true, or how it's going to behave, changes over time, then we have a unit test for it. So I don't really see the big value in keeping it as is. And he kind of went, oh, well, I agree with you in principle. It's just that I don't like it. He basically had this, like what I call emotional reason to why he didn't like it. And it's something that I thought was kind of funny, because a lot of us have this thing that, we don't like certain things based on emotion rather than, what I call pretty basic logic. I'm not trying to say that the way that I did it was correct, because once again I got that exact same question in my Klarna interview. But what I do want to say is that so far I think that, like, this idea where, if you have, even if it's a trivial thing, what value does it provide to keep it in the code without a nice abstracted method name? Because remember, and I told him this as well, I said, remember that if I'm looking at, I'm trying to figure out a bug, or I'm trying to skim this code, if you put logic inside, or if you add logic to my reading process, it's gonna take me longer to understand what the code is doing. If you create a nicely named function that I can just read, and then I don't have to think about it, unless I'm looking for the problem at that very specific place. But at the very least, if I'm looking, I'm going to be able to skim the code faster in my mind. And the argument against it I heard was, but well, if you're doing all these function and all these abstraction, because this is I've talked to what I call imperative programmers, or whatever I don't know if declarative or imperative, whatever, procedural programmers who, they want they want as few abstractions as possible. And I argue that the approach that they have is completely wrong, and here is why. The argument I got from this was from my previous boss. He was really upset with me for having this a rule where I said that if I see business logic, if you're plussing or ifing or elsing or whatever you're doing, or iterating or doing anything that's providing a value or a computation of some sort, put that in a named function. He really didn't like that, and he said, well, Frederick, whenever I read your code, all of a sudden, to understand what's going on, I have to click into all your function and follow the code, and then finally I realize what this function, what your logic is doing. And I said, but why are you doing that? Because the what you're looking for is most likely not to understand every piece of code that is in my entire, in the top level function. If you want to understand every single piece of this code, well, that to me sounds like a really weird way to approach the problem. Usually the bug, or the issue, should be solvable without understanding the entire code, the entire logic structure. And you say, well, I did something I want to do because it makes me mentally understand. To me, it makes things comprehensible. And then I said, well, his name was Michael. And I said, Michael, so when you are debugging your code, this was in C#. So when you want to debug your code and you see that there's a bug in you're creating an iterator and it's putting something in a collection, are you going into Microsoft's source code, like the .NET framework source code, to understand what's happening under the hood in that framework too? And he said, well, no. And I said, no, of course not, because you are conditioned, you mentally trust the code that the code that is written by Microsoft is well made. you understand their interfaces, but you don't go into their interfaces. You have no idea how a collection works under the hood. You have no idea how an array works under the hood or any of their functions. You don't know anything about it, but you trust that their documentation and the quality of the code that they have provided is good. I mean, you're not complaining about the fact that they are abstracting away all this logic from you. So why are you complaining about my logic? And he couldn't answer me. And I said, what I think the problem here is that you feel as if my way of writing this code is making you have a mental condition where you think that by understanding trying to understand the full scope of the logic is going to help you somehow, but it's the same process as if these abstractions aren't really taking anything away from you. They are simply helping you tune out the noise from the problem that you're trying to solve. So I argue that when you're solving a bug, the bug is very rarely the entire logic's tree that you're going through. That entire pipe isn't broken. It's usually broken in one or two places, tops. And that's the place that you're trying to find. So, because, I mean, if there was no value in abstracting things away, then, we would never make any libraries. There would be no code reuse would be impossible. So that's what abstractions are for. And I think, once again, this is an emotional thing rather than a logical thing. So what is this all trying to lead up to? Well, what I'm trying to lead us up to is that the way that I think about writing good, robust, well-made code is that my rule of thumb is, in essence, if you're creating some type of logic, if you're trying to make a computation, create the smallest piece of logic that you can make, and then you do the functional thing and you compose these things together and you grow things from there. But having the idea that you will understand everything in a large code base and doing the imperative thing, I think that's just something we used to do, that some coders are who basically they condition themselves to thinking in that way, and I don't think that they really have ever really written a piece of software that is so large that it becomes almost incomprehensible. I've seen functions in code where a single function can be several hundred lines of code long, and I've never spoken to, even imperative programmers will say that, oh, this is ugly. Procedural programming guys and girls, they will tell me that this is ugly, and I say, well, this is what you get when you don't think very carefully about good abstractions. And I argue that a good small piece of software or a small function that does something really well and is much more flexible than this procedural approach. It was a very similar question I got when I attended a Neo4j meetup, when Neo4j is a really nice graph database. And the question arose from one of the people in the audience who asked, well, I like Neo4j, but I don't like that it's really, if I have a lot of data, I can't get a nice overview of all my data. How do I do this? And I immediately looked at this person. I said, well, if you want, for a small data set, you can get everything in the database. But yeah, and then he kind of interrupted me and said, well, no, in a SQL database, you go to my tables, and then I look at my tables, and I just go step through the different pages on my table. And I said, well, that might work for a really, really small data set, but I don't think that's what you're doing when you have millions and maybe billions of rows of data. Even in a MySQL, this is not a problem with Neo4j. This is probably a problem I would say it's not a problem at all. It has nothing to do with the database. It's your data set. Even in MySQL or Postgres or whatever, if you have millions of rows of data, you can't step through all of that data. That sounds more like a problem on your end, that your approach to querying data and trying to get your, what I call, sense of overview, that's your approach. It's not the technology, and that's exactly what I'm talking about here. I will stick my neck out and say I think that small abstractions that abstract away, or small functions that abstract away business logic. I don't, a computation is almost always the way to go. The one thing I think is really important to make a distinction on, though, is that if you create a function that all it does is call another function without doing any computation, it's not doing anything conditioning, no conditions or anything like that, that's not a good abstraction. An abstraction on top of another abstraction doesn't provide any value, but an abstraction on top of logic is usually the way to go. And good names and that stuff, yeah, I think that that's going to make your code much nicer.